Yes, this is the second question, the section, the theory part of the 2025 West African Senior School Certificate Examination, and it happens to be a word problem question. Yeah, I understand very well that for many students, math is a problem, and even for those that like maths, word problem might sometimes seems to be like an Achilles heel for many people. So but then it is going to be very simple as I'm looking at it. I don't know where it is leading to. It could be a linear equation, a quadratic equation, anything. So let's just see. And the names I'm seeing here, they might be names that I cannot pronounce properly. So please don't be offended if it happens to be your name or something you know how to pronounce better. Just manage my pronunciation. So the product of the ages of Adu and Tanko is 9 less than Akofa's age. If Tanko is 4 years older than Adu and Akofa's age is 6 times Tanko's age, find Akofa's age. So when you see all these grammars, you might get confused. So the first thing is you always do in word problem questions for senior schools is that I would always advise that when you are solving word problem questions, you assign letter to the unknowns. So we are talking about the ages of three people here. And you notice that the only thing we have to find is Akufa's age. However, the ages are dependent. Someone is dependent on someone, and so we definitely will have to find the ages of others before we can find Akufa's age. So let's use a letter to represent all these three ages we have here. So my solution, I hope you can see my handwriting. Just manage it. So let's Adu's age be equals to x. So it seems so I would like using x very well in mathematics. Then let's Tanko's age. I'm not going to write in that long expression again. Equals to y. And who is the third person? Akofa. Let's Akofa. Let Akofa's age be z. So if you like using letter you like, it's fine. A, B, C, whatever. So I'm using X, Y, Z to represent the three ages. Now, you know the good thing about using letters to represent the unknowns is that instead of reading this with all these grammars, whenever you want to read this question again, instead of whenever you want to mention Adu's age, you can just put X, mention X. So that will simplify the expression. So the question can now be read as the product of the ages of Adu and Tanko is now the product of X and Y is 9 less than Akofa's age Z. So we can now read this as the product of X and Y is 9 less than Z. If Tanko, that's Y, if Y is 4 less than Adu X and Z is 6 times Y. So that is one of the reasons we use what's it called? We use letters to represent our unknown. So that makes solving our problem easier. Now let's go. They said the product of the ages of Adu and Tanko is 9 less than Akofa's age. Now what do we call product? So there are basically three operations in mathematics. That's what you know as your addition, subtraction. Sorry, four operations rather: addition, subtraction, multiplication, and division. So addition is usually called sum. Subtraction is called difference. While multiplication is called product. So product here means x times y. That's product of Adu and Tanko's age. So to represent this first statement now, the product of the ages of Adu and Tanko, that means x times y, which you are going to write as xy, is 9 less than, and if you notice in your in the y question, the bolding this they put this less than in bold form to draw your attention to it. So when I say for instance, I am 15 years old, then I say my age is 5 less than my brother's age. I am 15. So how old will my brother be? That means my age plus 15 will give you my brother's age. Get it? I am the younger one. That is why I say my age is 5 less than my brother's own. So if I'm 15, my brother will be 15 plus 5. Now, they said the product of the ages, the product of x and y is 9 less than Akufa's age, which is z. So it means when you have x and y plus 9 will give you z. So this can be interpreted in different ways. Someone might say z minus xy equals to 9. It still means the same thing. So I'm just trying to use the logic I use as regards my age now. That if I am 15 years old and my age is 5 less than yours, it means you are 15 plus 5. So the product of x and y is 9 less than z, means x times y plus 9 will be equals to z. So this is the first expression we have here. So if you like to to make things easy for you, you can call this equation 1. That is not really necessary, but it is fine. It is better. So that's the first thing I have here. Then let's continue. If Tanko is 4 years older than Adu, Tanko, remember we said that's y. So it means if y is 4 older, that's 4 more than Adu, x. What does that mean? It means if y is equals to x plus 4, y is 4 more than x. It means before you can get to y, you must add 4 to x. Y is 4 more than x. That means Tanku is 4 years older than Adu. So meaning Tanku's age will be Adu's age plus 4. So you can also call this equation 2. And the last expression we have here is that, and Akufa's age, remember what do we call Akufa's age? That's Z. Akufa's age, that is Z, is 6 times Tanko's age. Tanko's age is Y, is 6 times Y, that is 6Y. Z is 6Y. So all the, what's it called? The expressions I have here, I have been able to represent them with equations. So if what I've just said is not clear, I can just go back to the expression so that I don't make the video to be too long. So the 3 expressions we have here, the first one, the second, and the third, I have represented the 3 of them with an equation. So this equation seems to be a bit too complex. We have 3 unknowns, and how do we go about this? So all we can just do is, this is dependent. So I can decide to write all of them in terms of just one variable, maybe in terms of x. And the first thing I can do is that, we have z equals to 6y. We have an expression written in terms of y already. So I can say substitute, I'm not going to write that in full, equation 2 into equation 3. Equation 2 is y equals to x plus 4. And when you say 2 expressions are equal, it means they can represent each other. That is what it means. So if I say y is equals to x, what I mean is that wherever you have y, you can put x. And wherever you have x, you can put y. So when I say y is equals to x plus 4, what it means is that wherever I have y, I can put x plus 4. So by saying substitute equation 2 into equation 3, I mean wherever you have y in equation 3, just put x plus 4. So equation 3 will then become z equals to 6. Instead of this y, we now have x plus 4. 6 times x plus 4. And remember, that's going to give you, remember when you're opening brackets, you have to multiply, use 6 to multiply each of these terms. 6 times x will give you 6x plus 6 times 4 will give you 24. So this is the equation 3. You can call this equation 3 and you can decide to name it another equation, maybe equation 4. Not bad. So you have z equals to 6 plus, 6x plus 24. This is an expression we have here. Then another thing is I'm still going to do the same thing here. Also, okay, let me call this equation 4 to make things easier. So whenever I want to refer to it, it's easy for me to go back to it. Then I also want to do the same thing here. I want to substitute equation 2 again into equation 1. So that this equation 1, wherever I have y, I'm going to be putting x plus 4. So this is x. You write it's x. Instead of times y, you now have times x plus 4. The same thing I did with this. So x into x plus 4. Then you have plus 9. Plus 9 equals z. Notice the only thing that's changed here is that instead of putting this y, I'm now having x plus 4 in its place. Because they are equal. And since they are equal, they can always represent each other. So open the brackets here, that should not be a problem. X times s gives x squared. X times 4 gives 4 plus 9 equals z. I have been able to do something to equation 1 now. Equation 1 used to have 3 variables, x, y, and z. But now I have reduced it to just 2. That's x and z. However, it is still not possible for me to solve this equation. In mathematics, the number of, if you have 3 unknowns in an equation, you must have at least 3 equations before you can solve it. Now we have just one equation, but there are 2 unknowns. So I must find something to do with this. Either I reduce these variables here to just 1, or I find another way. And it is easy for me to reduce this equation to just one variable. How do I do that? Remember, your z has been written in terms of x. Z is equals to 6x plus 24. It means in place of this z, I can always put 6x plus 24. I don't want to have too many equations, but I think it will be better so that we don't get confused. The reason we just name all these equations is to make reference to them. So you might have your solution and you know be having this number of equations. It is fine. So what I'm going to do next is that I want this z to go away. And how do I do that? I'm going to substitute equation 4. Equation 4 is just z equals 6x plus 24. I will put it into equation 5. It means I'm replacing this z with 6x plus 24. So what I'm doing is substitute equation 4 into equation 5. And what does that give you? Everything here will remain the same since there's no z there. So I'm going to have x squared plus 4x plus 9 equals, instead of this z now, that is where the substitution comes in. We'll put 6x plus 24. 6x plus 24. Good news, I have just one unknown in this equation. So it's easy for us to solve this equation now. And you can see it. This is having the highest part of 2, so it is no longer a linear equation. This is a quadratic equation. Solving quadratic equation should not be a new thing to you. Okay, let's tidy up the equation first. So this is x squared plus 4x. I can decide to bring this 6x here. To meet its relative, they are both having power 1 for the x. So when 6x crosses here, remember that it becomes minus 6x. All I've just done here is to bring this to this side. Remember, we still have plus 9 on this side, plus 9. And I remember, you know how to collect like terms. I think you know how to collect like terms. You can still remember that. So plus 24 will also come here. It becomes minus 24. Now notice something. The two terms that are here, I have brought the two of them here. To meet the terms that they look like 6x to come and meet 4x, because they both have x to power 1. 24 to come and meet plus 9, because they both have x to power 0. That's why they are not having any x. These two terms are no longer here, so they are gone. So this is 0. So the equation becomes x squared plus 4x minus 6x. Simple. That'll give you minus 2x. Plus 9 minus 24 will give you minus 15 equals 0. So you can solve the equation using any method in the quadratic of solving quadratic equation. And remember, we have the methods like the factorization method, the completing the squares method, the formula method, and the graphical method. So the graphical method seems to be weird in this case, but you can use any of those methods. I feel the simplest method that I'm going to opt for here is the factorization method. I'm sorry, I'm not going to be stressing much on that because the topic is not basically on this question is not solely on how you factorize. Now, for a factorization method, if you can still remember, you need to find the products from here. You need two numbers basically. Okay, let me just try to show you some steps again. Always find products. Our product is always the last thing we have here. That's if you are written the number in the expression in correct order. The last number you have here with its sign multiplied by the first expression you have here. That's square. So minus 15 times x squared will give you minus 15x squared. Sorry, this is 15x squared. That is your product. Your sum is going to be the one left at the middle. So this times it gives you the product. Then the sum is going to be minus 2x. 2x. Then we need two numbers. That's talking about the factors. We need two numbers such that when you multiply them, that's products, you have minus 15x squared. And when you, or let me say, we need two expressions. And when you add them, you have minus 2x. So, and that wasting much of our time. The two expressions will be minus 5x and plus 3x. How? Minus 5x plus 3x. That's when you add them. Will give you minus 2x. And when you multiply them, minus 5x times plus 3x. Minus times plus is going to give you minus. 5 times 3 will give you 15. And x times x is going to give you x squared. So you use these factors to replace the sum. That's minus 2x here. You can still remember your quadratic factorization. And if you have forgotten this, you are free to use any method as I mentioned earlier. You can use your formula method, that is minus b plus or minus square root of b squared minus 4ac over 2a. It's fine. If you like, go for completing the squares method. Though I doubt anyone want to do that because most students always detest that particular method. Okay, so you are not restricted here. You can use any method. So the equation becomes x squared. You can write any of these numbers first. Minus 5x plus 3x. That's, you represent minus 2x with these two expressions. Then minus 15 equals 0. So the essence of doing this is we have three expressions here. Three expressions rather. And there's no way we can pair, we can arrange them in twos because there are three of them. So that is why we'll find a way of making this minus 2x to be written in two expressions so that we can group them into two. We can group this together, factorize, group this together, factorize. That is why we always find the factors. So x squared and minus 5x has something common to them. That is x. Factorize x out. So you are going to be left with x minus 5 in the bracket. Plus 3x minus 15x has something in common. That is plus 3. You'll be left with x minus 5 in the brackets equals to 0. And you remember, by the time you expand this bracket again, you must get this. X times x will give you x squared. X times minus 5 will give you minus 5x. Plus 3 times x will give you plus 3x. And plus times minus will give minus. 3 times 5 will give you 15. So these expressions are the same. So from here, you're going to have, you pick one of these. This is x minus 5. This is x minus 5. You pick just one of them. X minus 5. Then the terms you have outside the brackets, that's x and plus 3. They'll also occupy a single bracket, x plus 3. X minus 5, x minus 5, pick one. X and plus 3, put them together, equals 0. And when you have an expression like this, what this means is that either x minus 5 is equals to 0 or x plus 3 equals to 0. So you're going to have x minus 5 equals 0, or x plus 3 equals 0. And from here, it is either x is equals to, when you bring minus 5 to this side, it becomes plus 5, which is same thing as 5, or x is equals to, when you bring plus 3 to this side, it becomes minus 3. So your x is either 5 or minus 3. Remember, what is x? Come back here. X is Adu's age. So you have gotten Adu's age to be either 5 or minus 3. But something is weird. Is it possible for someone to be minus 3 years old? Never. So when you solve word problems, depending on what you are finding, if it is just a normal number, a number could be minus, could be negative or positive. But some things can never be negative. Things like age. Someone's age cannot be negative. You are finding a particular dimension, maybe you are measuring a length or someone's height. Those things can never be negative. So when you solve a word problem in such instances and you get a negative number, you discard it. So in this case now, our x is going to be just 5. We'll throw away this minus 3. Why? Because it is not possible for an age to be negative. So x is just going to be 5. And that is Adu's age. What we were told to find is what? Remember, we were told to find Akufas age, which is z. And you remember that z is equals to what? 6x plus 24. Now that you have gotten x, you can get Akufas age, which is z. So we say substitute x equals to 5 into the equation that has Akufas age is equation 4. Z equals to 6x plus 24 into equation 4. So that z is going to be equals to, instead of 6x plus 24, it becomes 6 into brackets 5 plus 24, which is equivalent to 6 times 5, 30 plus 24. And that's going to be equals to 54. Therefore, z is 54, and that means Akufas age, as we were told to find in the question. Akufas age is 54 years. That's Akufas age. And you notice something? We did not find y at all. Why? If in the question you were told to find the ages of the 3 of them, you will you will need to find y. But here what we were told to find is just Akufas age. The reason I needed to find x first, that's Tanko's age, Adu's age first, is that Akufas age, which is z, is dependent on Adu's age. So that is why I have to find it first. And the good news about word problems is that you can confirm if what we did there is correct or not. How do we do that? Now I'm done with what I'm supposed to do here. Now let's quickly do a rough work. We already got that Adu's age now is 5. So Adu is 5. That's x. Adu is 5. Sorry. Adu is 5. Then we said Tanko, which is y. We said y is equals to x plus 4. So we said Tanko is 4 years older than Adu. It means Tanko is going to be 5 plus 4. So y is going to be 5 plus 4, which is going to be equals to that's 9, right? So it means Tanko is 9. This y is Tanko 9. Then Akufa, we got his age to be 54. Now let's try if the answers I've written here go in line with the word problem here. The product of the ages of Adu and Tanko means 5 times 9, which is going to give us 45. Is 9 less than Akufa's age? What is Akufa's age? 54. The product of the ages of Adu and Tanko is 45. Definitely 45 is 9 less than 54. Because by the time you remove 45 from 54, you're going to have 9 left. That means 5 times 9 is 45 less than 54. That is settled. If Tanko is 4 years older than Adu, you've seen that here. 9 is 4 more than 5. So Tanko is 4 years older than Adu. And Akofa's age is 6 times Tanko's age. What is Tanko's age? 9. What is 6 times 9? 54. All the conditions are fulfilled. So when you solve a word problem question, it is very easy for you to check if what you have done is right or wrong. If my answers do not meet any of the conditions, any of the statements, then I know something is wrong somewhere. And with this, will come to the end of this second question too. Thank you for listening.